Two capacitors of capacitance 20 picofarad and 50 picofarad are connected in series with a 6-volt battery. We have C1 as 20 picofarad and C2 as 50 picofarad, and they are connected in a series with a battery of 6 volt. We have to calculate the potential difference across each capacitor. So first of all, let's calculate the C equivalent of the circuit. Now since these two capacitors are in series, so 1 by C equivalent is equal to 1 by C1 plus 1 by C2 gives 1 by 20 plus 1 by 50. So C equivalent comes out to be 20 into 50 divided by 20 plus 50. Now we know that Q is equal to CV. So for that we have to calculate the charge on each of the capacitor. So charge on each capacitor will be capacitance, that is 20 into 50 divided by 20 plus 50 into potential, that is 6 volt. Now this is the charge on each of the capacitor. Now if this is the charge on each of the capacitor, then again using the formula Q is equal to CV, with the same charge with capacitance of each of the capacitor, we have Q as 20 into 50 divided by 20 plus 50 into 6. This is the value of our Q, that will be equal to C. Let's say if we have to calculate the potential drop across 20 picofarad, so capacitance will be 20 picofarad into V. So V comes out to be 1.7 volts over here, and let's say it will be V1. Now to calculate the potential drop across 50 picofarad, we simply use the concept that the net potential drop across the two capacitor will be 6 volt. So potential drop across 50 picofarad will be equal to total voltage, that is 6 volt, minus potential drop across 20 picofarad, that is 1.71 volts. That comes out to be 4.29 volts. That is the answer. Now in B part, we have to calculate the energy stored in each capacitor. So simply energy is given by half of Q square by C. So let's say we calculate the energy across 20 picofarad, name it as epsilon 1. We have half Q is of course given as 20 into 50 divided by 20 plus 50 into 6, it's whole square because this is a charge, whole square into capacitance, that is 20 picofarad. On solving we get it as 184 picojoules. Similarly, second energy across 50 picofarad is calculated by the same formula, that is half of Q square by C. Here again the charge will be same, as the two capacitors are in series, so the charges on both of them will be same. So it's square into 1 by C, that is 1 by 50 picofarad. Now solving this we get energy as 73.2 picojoules. That is our answer.